Welcome, everybody. Thanks for attending. The topic we are going to discuss is the GitOps principles for applying for the alerting management. Before starting it, just a small introduction. My name is Pradeep. I'm working in Swiss Re as a site reliability engineer, mainly maintaining observability platforms. I come from the background of Elastic Stack. Very heavily used. Some of you, I already heard the name of Influx, so I think people know TickStack. It's the Influx, not the chronograph part. I love Grafana before chronograph. So, and then now moving or shifting towards the Loki, Grafana, Tempo, and Mimir stack. And my colleague. Like
Hi, my name is Juraj Michálek. I also worked at Swiss Re, and I'm an SRE with focus on observability in my free time, but also during work I contribute to Altel and the Looks Good to Me stack. And I'm also active in the Altel Prometheus working group. And now I'm also in LFX mentorship project under Arthur, David and Arve implementing remote write 2, which was already mentioned before, in the remote write exporter of the Altel collector. And I also recently became a Grafana champion.
Can't beat that. Thank you. So before going to the problem statement, here's the quick look at our landscape or the architecture. As you can see, we use mostly all the components from Grafana, Mimir to Loki for logs, and Tempo for traces. All the visualization happens at the Grafana end. All these sources comes and connects there. How we take the metrics, traces, and logs from the users is basically, as you can see on the left-hand side, you have the customers' Kubernetes clusters, even though some customers don't have Kubernetes clusters, so they have their services. They can send their metrics and traces on HTTP or gRPC. We have this OTL collector at our end, pretty basic standard, basically, nothing much in there. Use alert manager heavily. And on the right-hand side, you see there is something which is not native Grafana ecosystem, is Elastic. Basically, we use Elastic Stack heavily for our logging. And why we use that, we will come in the next slide. We have our in-house system of event management. It's very tightly coupled with our standards in terms of like alerting correlations. With the data, what we have, it's very smart system, which basically correlates, merge the alerts, and generates an event which is more meaningful, avoiding noises and things like that. And then pass it on to different channels like Teams, MS Teams, ServiceNow incidents, emails, SMS, pagers, even some more automations as well on forward side on the upstream as well. Why we have this system is because, as you can see in the screen, we are the observability platform, but more than observability platform, we are a data shop. We kind of have 20 tera data every day ingested in our systems. We have like 9 or 10 million active series at the moment, time series. And heavily used. We are very distributed system. There are a lot of IT teams which basically comprises of developers, SREs, auditors, governances, all these things. We have security colleagues which are using this data to do day in, day out cyber defense for them. So we are one-stop shop for the entire organization as a cyber defense platform as well as the IT operation platform. And that's why it becomes important to adopt to GitOps. Why GitOps? The problem statement comes here. As I mentioned, like we are a central team. We basically do a lot of things. We provide these platforms, but we cannot keep up with the things the customers or the different IT teams demand from us. They want to set up thousands of alerting rules. They want to set up thousands of dashboards on their demands. And if a central team does that, it is not very meaningful. That is why GitOps. Why GitOps? It is A, collaborative, B, it's readily reconcilable, or you can reconcile on the go, ready to go. It is declarative. You know what is going on in your infrastructure. That is why. So the problem statement was how we can take help or spread our work to the teams which know their data best to contribute into their data itself and manage it centrally. Solution part comes in very simple, very straightforward, and very basically what we did was nothing new. We have been doing it in other tools as well. Like as I mentioned, we are using Elastic heavily. And in Elastic End itself as well, we use the same principles. So it was just bringing this also into the ecosystem. That's why we do that. So the solution is, as you can see here, we have in our AKS cluster the Mimir ruler. We just attach a sidecar to it, which is Git sync. And there is a repository. We heavily invested in Azure cloud. So the repository rules repository lies into the Azure Git. And there we have kind of people collaborating, contributing to their rule sets and all that thing. And then the Git sync will basically reconcile what you need actually on a regular basis. And at any given point of time, you basically don't have to deal with managing the config maps and things like that. And then everything is declarative there. So that's how this functions. The sync car, basically what you can see here is the setting. You can configure it as per your need. We basically do it like a reconciliation interval of 1 minute. You have the repo defined there, which basically use the rules set up there, and then kind of have it on the state. There are two things which are very important in that, and why we did that is because we wanted to keep the spaces for different teams. So as you can see here, there is a folder structure for the rules. So we basically apply the same principles for the rules based on the metrics, as well as where we are using Loki. The rules for the Loki also go in the logs directory. And within the metrics, then you have team A, B, C, whoever is there. They can set up their alerts in a YAML specification. They can also set their rules, recording rules as well. And that goes per team. It's important, like when different teams are contributing, there has to be a quality control. There are very heavy standards in terms of what we bring into our system, and not to overblow the upstream systems as well with like floods of events or things like that. And that's why we bring a validation as well. So as and when the PR is raised, there is a build which basically validates. We use PromUL, as well as there are certain logics which actually determines that the rules contains specific labels which are important to upstream systems like the event management to correlate rules, have a parent-child relationship, deduplications, and whatnot. So this validation is very important. This is like a first line of defense for us, basically to make sure nothing is going out of hands, everything is in control. And the amount of validation happens on the rules is a bit more stricter. In dashboards, basically it's a JSON. The principle goes the same. Under that, you have like the dashboards and the dashboard JSONs, basically. And we validate or kind of use a linter to see if it's a valid JSON. And this has less harmful effects if something is wrong rather than in alerts. So stricter validations on both ends, specifically more on the rules side. So how it works is the flow is basically any team which wants to contribute, they know their data, or they want to take help from us. They raise a PR with a set of YAML specifications on what they want to do, what kind of rules they want to set up. When the PR is raised during the build time, a validation pipeline runs, which actually checks out whether the rule actually met the standards of required labels are available or not, the time intervals are there or not, the frequencies, the warning labels or alert severity labels as per se, all these things. And any given point of time, if this build pipeline fails, it gives a clear message that, OK, the the PR which is raised, it has these defects, and then that can go that direction. And then, of course, it goes with the PR review, which is one of our team members who would actually approve the pull request, and then it gets merged. So I think why not we can show it in a demo mode.
Yep. So as part of the demo, we're going to add a new alert and a change a name of a dashboard. So just to be on the safer side, I already pushed a pull I already pushed these changes in a pull.
I think we cannot see it.
Oh.
Screen.
Oh. Should I reconnect it? Nope.
I think there is a.
There is some error message in German.
Yeah.
No, it's just that.
Oh, no,
Okay.
exactly.
Now it's up.
Good.
So I already made these changes a few minutes ago, but basically I pushed a commit in a branch that changes the name of one of the dashboards and adds a new alert. And it keeps going away.
Yep. It's all good.
So now we can create the pull request with these changes at our dev repository. And because it's our dev repository, in this case, we don't actually require a review. So I can just set it to autocomplete when the validation pipeline finishes. And in the meantime, we can go look at the validation pipeline. So as Pradeep mentioned, use PromReval to enforce certain Swiss Re specific standards around, especially around labels. And in the pipeline, we just basically download it and run it against the Mimir alerts and recording rules, and also against the low-key alerts and recording rules. We also run PromTool. We use that to execute unit tests, Prometheus unit tests if they're present. They're not mandatory, but if they are present, if the unit tests don't succeed, we fail the pipeline. We also have unlimited validation for the Grafana dashboards. And also we check if the provisioning configuration of Grafana points at folders that exists. And we also run a low-key tool just to double-check the low-key files have correct syntax. And because this pipeline passed, the pull request is now merged. And we can go into our demo instance. And in a bit, we should see that it's going to create another alert. OK, so we see already the git sync succeeded, and now we can see that the ruler is creating a new alert. One thing that's very useful is the git sync sidecar also produces its own metrics. So we have a dashboard and set of alerts for it. So here we can see it's most of the time it's doing no op, but now it's actually fetching the changes, so we get the if it's exceeded or not. We get also what is the average latency, and we also use some other metrics to monitor the git sync sidecar for failure. We also have its logs through Loki. And we should also see, this is the dashboard we edited, so if we refresh the page, we see now that the name of the dashboard also changed from V4 to V5. I guess that's it for the demo, so we can go back to the slides. Nope, wrong view. Sorry. Oh, okay. As I mentioned, in the pipeline, we run the unit tests. We don't enforce them because they're kind of tricky to write, and it's also time-consuming. but they are definitely useful when you have some complex alerts and you want to make changes to them. The unit test can help you ensure that the alert will still fire under the conditions you set. But there's also the other downsides with it, that it's like you have to mock the data you use for the unit tests. So if you make some typos in the mock of the data and also in the alert, and it will not match the actual data in Mimir in our case, that will not get detected by the unit tests. We also, as I mentioned, validate the alerts. So we ensure that there's a minimum range interval in the queries. Because of the escape interval we use is 1 minute, so the range queries need to query at least 4 data points to work properly. We also have a minimal evaluation interval enforced for the rules, so somebody doesn't configure them to evaluate too frequently, causing issues with the Mimir ruler. There's also a built-in limit for maximum number of rules per group within Mimir, so we also check for that. We also run some validations on the expressions themselves, that there are valid PromCon expressions and that the templates used in the labels and annotations are valid. And we also enforce some Swiss specific labels. On the dashboard side, we validate that it's a valid JSON, that the provisioning config is correct, and that the folders that it's pointed at do exist. So this is what the syntax of the Prometheus unit tests looks like. So at the top, we define the alert file we want to run the unit tests against. We also define the evaluation interval that should be used for the tests. And then in the input series, we basically mock time series with certain labels. And in the value section, we mock its data. And then in the alert rule test, we say that at the minute 15, we expect alert alert with the alert name tempo request latency to fire with these expected labels and annotations. And then PromBruval. So this is sort of what the syntax of the configuration file from PromBruval looks like. So at the top, we define validation rules, and each rule then has a name and either a scope of a group or an alert, or all rules, and each of the rules then enforces a certain one of the conditions we talked about before, such as, for example, the first one is the maximum number of rules per group.
20, right?
20. We also enforce, as I mentioned, for example, a certain set of severity is a mandatory label, and we also enforce values that are allowed. We also check that we have a team label on each alert, so there's clear ownership, and we also run some default upstream validations. So there are some limitations, however, to this setup. We definitely have seen problems when, for example, we cannot reach Azure DevOps. So in that case, the Git sync cannot pull new changes. And in case, because we don't have persistent volumes in place for this, in case Mimir ruler instance, the pod would go away, a new one is created, it cannot start because we also have a init container with the git sync to prefetch the rules before ruler starts. So in that case, that would fail. It is a limitation due to we use the Helm charts, so we haven't forked them yet. So we don't have an easy way to add the persistent volumes there, but that's something we want to address. Also, the way you configure how the Mimir ruler loads the files from the file system, it's a bit less flexible than, let's say, with Prometheus and Thanos. So that also forces us to use a certain folder structure. But we have an open issue for it, and it has been accepted as when we find the time, we can make it a bit more flexible to basically mimic the behavior of Thanos and Prometheus. So as Pradeep mentioned, right now all the alerts have to be reviewed within the team that created the alert, but also by our team, just because it's a bit newer technology in our company. So we want to make sure that that the alerts are sane and that they won't cause any issues. But down the line, we would like to allow the teams to just have a review from within their team. However, because of lack of code owners, for example, like you would have in GitHub, that will be a bit problematic with Azure DevOps.
Yeah.
There's other alternatives we have also considered. So instead of what I guess most teams would use with Mimir, is instead of using the Git sync and loading the alerts from the file system, they would upload to S3 from the pipeline. But we went with this approach, as Pradeep mentioned. One of the reasons was because we do something similar already for Elastic alerts. We also considered using Argo CD and basically storing the alerts as config maps in Kubernetes. And Argo CD is used within our company, but it is not yet used by our team. So that's why we also didn't go with this approach. And there's also a third option, which could be building a Helm chart with all the alert files and deploying them again as config maps into the Kubernetes cluster. But there you can run into limitations around the Helm charts, which is the maximum size of the Helm chart. So that's why we also didn't choose to go that way. And that's it for the talk. Here's a list of references if anybody wants to take a picture when it works. So please, yes. So we link to the GitOps principles. There's also a demo repository where you can see this set up and try it for yourself. We also link to the prom rule, which is maintained by one of the other speakers. If you have a feature request, you can bribe him with a beer and he'll make them. And then also links to GitSync, the open issue for Mimir. I also recently raised an issue for GitSync around adding a mixin for it, and some of the other tools. And there's also dashboard linter from Grafana, which we might end up using at some point. That's it. I guess thank you for listening. Any questions?
I think the screen is also waiting for the lunch.
Yeah.
It's flickering around.
Questions? No questions.
I guess lunch it is.
Yep.
Not yet.
Damn it.
Good job. Everybody
are hungry.
wanted to go to lunch.
Hi there. How many rules do you manage with the system, and how many do you foresee in the long run?
That's something I forgot to look up, but I would
I think we have roughly around 1,200 rules in the existing system of Elastic. In the current observability with Mimir, we have, I think, 300 something. But the expected number, since we are kind of now adopting this, so that would also go 1,000 plus. So we would be maintaining roughly around 2,000 rules. Yep.
One more here.
Hi. Can you go over once again on the numbers, the number of active series you get on Mimir, and can you give some figures about how big is the infrastructure allowing you to serve them? So
we are kind of a multi-cloud organization. We are in Azure. We have our in-house private cloud as well. We're based out in Switzerland, so there are some regulations to have the data there as well. We have a China market as well, so we have Ali Cloud as well. So we are like multi-cloud company, and that's why even though Kubernetes is an adoption, it's not fully there. We still have native systems, say, be it like old set of Cloud Foundry-based systems, or even mainframe is still there. So we have roughly around, at this moment, 11 million. The expected number would go roughly around like 20 million by end of this year, if I'm not wrong. But we don't know the exact number, how far we grow or how extensive we will go. But that's the number, actually, right now.
how many resources do you need to deploy in order to be able to serve all those metrics?
So I think we currently have like we have our environment in Azure. So we have like the infra with like 9 nodes of a Azure Kubernetes cluster.
I think it's right now like roughly 12 ingesters with 20 gigs of memory limit with the multi-AZ setup in place.
Yep.
And this, like we have, I think, auto-scaling enabled on the distributors, so they go up and down. But because it's a Kubernetes cluster, so when we need to, we can just, we have auto-scaling on the nodes too, so
Yep.
We can just add more nodes. We haven't really hit any performance issues so far, at least not with Mimir. We have an ongoing latency issue where we're investigating actually with our ingress controller. But I think there's going to be a talk later about some potential performance issues we can hit with Mimir at bigger scale.
Yep.
Hi. Depending on alerts, like usually when you are monitoring something, you heavily depend on alerts to make sure that the thing you are monitoring works. So making sure that the alert works also seems very useful.
Yep.
That's where you come with the alert unit test, right?
Yep.
But I don't see people talking about that very often.
So it's...
Why do you think that is? And what is the problems that you are finding when you're implementing these tests?
So I think part of it is people just don't like writing unit tests, right? And the other one is we try to help with documentation, but it's sort of, they are time-consuming to write, right? So and you always just mock the data. So if you make a typo in the mock of the data and in the alert, your alert still won't work because if you make typo in both, like the unit test will pass, but it doesn't necessarily reflect the actual data in your instance. So like long-term, what PromRuval also offers is it can connect to Mimir and run some validations to compare, for example, that the metric name, I think, that the metric name you're mentioning in your alert actually exists. So I think that's one approach. In one of my previous jobs, we did enforce presence of unit tests. So we checked that each alert file had its own corresponding unit tests. But I'm also not sure if that's the right approach. In that company, there was a very, they were early adopters of metrics. So the developers were already used to writing the unit tests to a degree, and we also helped them with ample documentation. But in a place where the technology is newer, I think we then don't enforce it yet, just to lower like the barrier to entry, because I mean, yes, it's better to have the unit test, but if the person is like, okay, I'm not going to add the alerts because I don't have the time to write the unit tests, it's better to still have at least some alerts, even if you don't have the unit tests for them.
I think we should encourage people. I think there is a learning curve also required, but that's a good question actually, that unit tests are very, very important. So we are in the tendency to encourage, but there are sometimes it requires a learning curve for the people to actually adopt to that as well. So yeah.
All right. That's it. Thank you again.
Thank
Big
you.
round of applause.